Guys, we have what is called cyclic quad, and cyclic quad is not, it's not that hard. We only have few theorems to focus on in cyclic quad. Okay, and actually we only have few conditions. Let me not say theorems. Few conditions to focus on when we have a cyclic quad. In order for us to have a cyclic quad, we have to have 4 points that are touching the circumference of a circle. Then, which means that we have a quadrilateral in a circle. That's why we call it a cyclic quad. So we have to have 4 points touching our circle. Can firstly have that, or we can have a circle. As long as you have 4 points, doesn't matter where they are. Let's remove this and have that. Can give you a weird shape, it's fine. As long as you have 4 points connecting and they are all in the circumference, then you have a cyclic quad. That's how we prove cyclic quad, or that's how we analyze cyclic quad, sorry. But then for proving, we have to focus on certain things. We don't necessarily prove cyclic quad. What we prove is the properties of cyclic quad, like proving opposite angles of a cyclic quad. What does it mean to have opposite angle of a cyclic quad? What must we have as a value for angles opposite in a cyclic quad? Proving an external angle of a cyclic quad. Why is this external angle of a cyclic quad equals to this angle? We are proving the properties. The reason why we need to prove the properties of a cyclic quad is that even if we are not given a circle, as long as we can prove one of the properties of a cyclic quad, then we would prove that the shape is a cyclic quad. Yeah, I hope you understand exactly what I'm trying to tell you. It's all about cyclic quad here. So let's focus on the properties of a cyclic quad that you guys have to master, so that if you are given any question, you know exactly what to do. So the first one is opposite angles of a cyclic quad. So we've got our cyclic quad. Then let's name A, B, C, D. Opposite angles of a cyclic quad are supplementary. This means that angle B plus angle D should give me 180. Angle A and angle C should give me 180. That's what we have as our cyclic quad. Now, what's gonna be next from here for next week's lesson? We'll be proving that. We'll be proving this. So during your spare time before Saturday, may you try to research about supplementary angles in a cyclic quad. And what is also important is having um, an exterior angle of a cyclic quad. So we've got, can have this set up. This is a cyclic quad. Four vertices are touching circumference. So an exterior angle of a cyclic quad, if I have x here, then this should also be x. That's what the theorem states. So we are also going to prove this in the next lesson. Just take note of the properties of a cyclic quad. These are the most important properties of a cyclic quad that you may have. There are more of them. We can have a circle. We can also use the concept of, when we have a cyclic quad like this and we have a center, and let's have diagonals. You will see one of the most important things about a cyclic quad to take note of. Diagonals are line passing through the middle part of a shape, and the vertices crossing each other like that. Now here's the thing. We can take note that we've got this angle subtended by, let's have this as A, B, C, D. Then we have 1, 2, we have 1, 2, like that. Angle C1 is subtended by AB, as well as angle D1. So these are also properties of a cyclic quad, that when you have angle in the same segment equal, they have to be equal. If you didn't have, say, a circle and you had to prove that this is a cyclic quad, and you can prove that this angle is equals to this angle, and this angle is equals to which one? Is subtended by CB. We search for a possible angle subtended by CB. We've got it, this one. So you have to be creative when you're proving a cyclic quad, and it will all depend on what you are given. So that is what is important. So proving that C1 is equals to D2 from what we have proven already, angles in the same segment. Then we have a cyclic quad using the concept of angle in the same segment. If you can prove that the whole of C is supplementary to the whole of A, then we have a cyclic quad. Opposite angle of interior angles of a cyclic quad that are opposite to each other are supplementary. Lastly, if you can prove that an external angle somewhere here, B, maybe 1, 2, 3, B3 is equals to the whole of D, then you have an external angle of a cyclic quad. So there are three possible ways of proving a cyclic quad. 1, 2, 3. Proving supplementary angles, interior angles that are supplementary. The first one. The second one is proving angles in the same segment. Then lastly, we can prove that the external angle of a cyclic quad is equals to the opposite angle. You don't have to prove all of them, just have to prove one of them. That's how you prove a cyclic quad. Okay, guys. I hope you enjoyed today's lesson. I think I tried to push it. If you have past papers related to Euclidean geometry, here's the thing. We are still on the concept of Euclidean geometry. You post the past paper or whatever questions that you are currently working on. You post the picture on the group. That will buy me time to prepare for the next lesson. For the first 30 minutes, we work on those questions. For the last 1 hour, 30 minutes, we focus on the lesson of the day. Okay, so we are done for today.